Thank you for joining us here on Scrubbing In. I'm Todd Schlosser, and joining me today is Andrew Goldstein, and he is manager of biomedical engineering here at SpecialtyCare. And I like to start off with this question because it's a question that sort of interests me as someone who didn't enter the medical field immediately when I got out of school. What is it that drew you to that medical field when you were going through school, or maybe even picking what you wanted to do as a major?
My major was actually biomedical engineering.
Oh, yeah.
Prior to that, growing up, I always had interest in both electronics engineering and medicine, kind of shifting back and forth. Somewhere in high school, I did a project and stumbled across biomedical engineering, and it just seemed to be a great mix of the two. And as I went into college, I kind of decided that I'd make a better engineer than I would a doctor. So I went, I'm a little squeamish on such things.
You mean like surgery?
Surgery
I
thing.
completely understand that.
Well,
Yeah.
It was odd going into surgery type field with that, but
Sure.
But definitely the engineering side and still having that attachment to healthcare was what interested me.
So, and when you went to school, you did your biomedical degree, right?
Right,
bachelor's. And then your bachelor's in
engineering.
Right. And so when you left that, what path did you take?
So initially I was looking at going to work for medical device manufacturers
Sure.
or things like that. This was a few years ago, and there weren't very many undergraduate biomedical engineering programs.
Right.
So the manufacturers didn't really know what to make of us. So most went into graduate degrees and such.
Sure.
I happened to find a position with a research division at a hospital.
Oh, okay.
And got involved with one of the pioneers in intraoperative monitoring.
So you just, wow, so you sort of just applied for a job and ended up sort of with the, and forgive me, I don't know his name, but the person who sort of pioneered intraoperative neuromonitoring as a field of study.
Right. Richard Brown had, as his PhD dissertation at Case Western Reserve, which is where I graduated, he had built the first computerized evoke potential machine for use in the operating room.
Oh, wow.
And he was continually revising it. His first one was done in the 70s. By the time I joined him in the late 80s, he was on the third revision,
Sure.
major revision of the system. So he hired me to design and build that, but he also wanted anybody working on it to know actually what it was doing. So actually, before I went into the lab to design, my first day on the job was a 12-hour spine case.
Your first day on the job?
Yes.
They were like, welcome to this new company, Scrub In, you're going to be in a spinal surgery.
It was, you stand here, watch what I do.
Sure. I mean, of course they weren't letting you like cut someone open or even make calls about monitoring.
Right.
Yeah.
But this is what we do, and this is what you're going to be doing half your time.
So if they want someone to wash out quick if they can't handle that, which of course you were able to handle and you stayed with them. But
yes.
So that's very interesting. So you not only helped design sort of the third iteration,
right,
and maybe other iterations that came after,
yes.
But you were also trained on how to do the functionality of the job itself.
Correct.
So you did more than just put the mechanics in the box. You actually made sure you knew how to do it.
Right. We would go in there.
That's a really good idea.
It was it was good. It was how that was built. It was also, for me, just graduating as an engineer was fun. It was a lot of fun. I had grown up doing electronics projects and hobbyist and things like that. Sure. But to build a machine and then use it in the OR and then the next day roll it up into the lab and let's make some changes. And then the third day roll it back into the OR and see those changes. These days, you probably couldn't get away with that as much.
But it was such a new field.
But
then.
It was a new field.
Yeah.
We were under the research division of the hospital.
Yeah.
So we had all that support. We had the support of biomed checking out the equipment, making sure it was safe for the patients. But we did all that, and it was a great time.
Yeah, that's fascinating. So you would have cases where you would be in the operating room, and you would see something that I don't know. Maybe you're like in your mind, I wish the engineer had done this differently,
right.
And you the next day were the engineer that you had given that feedback to.
Right.
That's incredibly interesting. And also I think very valuable because I think in a lot of and maybe not just healthcare fields, but I've noticed this in some things, the people who use the instruments and the tools aren't the ones making them. Mm-hmm. So there are a lot of iterations before they get it. They find the happy marriage between the engineer designing it and creating it and the person who's actually the end user of it, if that makes sense. Yes. So you were both of those
Seeing
people.
Both sides.
That's very interesting, and I think very forward thinking of the person who hired you.
Well, it wasn't. It was what he was also. He was an engineer who had gotten into this and been involved in healthcare, and he just had a great love for patients and patient care. So it was a great way to do things.
Yeah. It seems like it. So how long did you work on that project?
So I was there for just about 10 years.
Oh, yeah? So you really watched, maybe not the birth of IONM, but you sort of came on shortly after its conception and then sort of fostered it through its infancy then.
Right. That was the era when the commercial systems were starting to be produced.
Sure.
So by the end of that period was when some of the equipment that we're still using in the ORs now was first introduced.
Yeah.
We actually, myself and Dr. Brown, took the system that we had and put it through FDA approval. So before I left there, it was actually an FDA-approved device ready for sale. Unfortunately for us, but fortunately for patients in the community, the commercial manufacturers had gotten into it, and with their resources, they had surpassed what two people could do on their own.
Sure.
And computers had kicked in really significantly at that time.
Yeah.
When I started, we were still using old microcomputers, which are the size of a refrigerator.
Yeah, they're not very micro.
No,
yeah.
No, but that was what they called micro.
Yeah.
And by the generation that I was working on and the subsequent ones, we were on PCs, and Windows PCs came out.
Yeah. You started on this, and even Dr. Brown started on this before, there was a computer in every home in America.
Right.
Like, it was, you wouldn't even see people building them in their garage in the late 70s. Like, that was, that's why Steve Jobs and, Bill Gates took off so well, because they were the people who kind of pioneered that technology.
Right.
And he was doing that around the same time.
Yeah.
That's amazing to me.
We even did things in the early 90s. We were actually doing remote monitoring.
In the 90s?
In the early 90s, the web came out in 93.
Yeah.
We were doing remote monitoring where we had the equipment set up in the operating room, and we were running over a phone line to Dr. Brown's office.
Just regular dial-up.
Dial-up on the other side of the hospital, so he could view the cases remotely while somebody else was in the room doing some monitoring.
You didn't have bandwidth issues? Like a 56K modem or whatever?
That seems so insane. This is why we were only going
across the hospital.
where he was 2 minutes away.
Yeah.
We weren't going across the country at that point.
Yeah, so if you needed to, he could sprint down.
Yes.
Yeah.
Yes.
Okay.
And that's really most of what it was. It was to let him know when
he needs to kind of get out.
When the slow points in surgery were, or when the points that needed his attention were going on, but that way we could also monitor continuously throughout. That's amazing. There, even without him in the room.
And that's something that we still do to this day. We still do remote monitoring.
That's
they're further than the hospital away.
Oh yeah, that's an essential element of monitoring today.
It's a very, I think, it's like a safeguard system. It's like having two surgeons there in case
two sets of eyes on the data.
Yeah.
You have a continual source of consultant in reference, and it allows the service to go to more areas than it was. The service intraoperative monitoring started out only in university hospitals, and didn't go beyond that because there weren't enough people to spread beyond that. Technology has allowed it to spread well beyond the original.
So you and Dr. Brown sort of helped start and sort of pioneer where the technology went, and for about 10 years you did that. Where did your career go after that?
At that point, I went for a few years to work with one of the manufacturers, helping a little with development, but actually it was mostly a sales role that I was there because I had the familiarity to go into the OR with the equipment and really describe the equipment to the end users.
Yeah.
So I did that for a few years, but sales wasn't really my calling.
Sure.
I was more interested in the patient care side of things.
Sure.
So after a few years of that, I went to work for a small company that worked pretty much the same as SpecialtyCare, had mobile equipment and sent neurophysiologists around to do monitoring at different hospitals.
Right. Pretty much the same business model we have then.
Right,
Yeah.
but on a much smaller scale.
Sure.
I also did some of the technology for that company, established their remote monitoring program, and oversaw their equipment to an extent.
Yeah.
And I stayed with them for about 8 years, traveling around and doing that until the traveling portion of it got a little old for
Sure.
me.
Yeah. You got to strike that good work-life balance.
Right.
Yeah.
One of the issues with the smaller companies is that their accounts were so scattered. I'd be driving 2 hours one direction one day and 2 hours the other direction the next day, and kind of waving at my house in the middle of the night as I went past.
Yeah.
So yeah, that got old. I very briefly went back to another manufacturer that was looking at expanding their IONM product line, but it turned out not to be the right time for them to invest in it. So I was there briefly, and then met up with Surgical Monitoring Associates, which is one of the companies that SpecialtyCare eventually acquired.
I actually recognize that name. Yeah.
Right, Tony Sestokis was there. I went to work for them, not as a clinician, just as head of their biomedical engineering and their information technology departments, and built that up, and eventually got acquired by SpecialtyCare, absorbed into the information services department here, and being that it was a much larger group, I was just responsible for biomedical engineering over intraoperative monitoring equipment.
But that actually has changed recently, right?
Yes, I just took over responsibility for the perfusion biomed group as well. So now I'm manager of biomedical engineering for both service lines.
So now you're sort of managing those who actually go out and repair the equipment.
Repair, maintain, inspect.
I mean, having done it yourself for 20 years.
Yes.
Yeah.
That helps. That's where I got into it in the IOM side. The IOM side, we also do technical support of the equipment, where our clinicians in the field, if they have technical problems with the equipment, especially with the computers and the hardware, they can call us, and we can support them and help them with that, since we have the understanding of the electronics and the computer components,
absolutely.
which most of the clinicians are very, very good with that, but it's not their focus.
Sure.
I've had the extra exposure to that and can evaluate that sort of issue.
Yeah.
And we've trained our engineers to do the same, and they're very experienced on the hardware portion of it.
I'd imagine it's a different skill set. I mean, maybe not high level, but once you get into it, because you're still looking at the electrical wiring, one's of the body, one's of an actual computer system, and the components that you hook up to the actual patient. But people who are working the IONM part of it, the techs that are actually in the OR are focused on patient care, and technicians are focused on making sure that they have the best equipment they need to be able to provide that patient care. Both valuable in their own respects, but very different. Although you have a background in both.
Right, and that's leads to my focus of my team's main responsibility is making the clinician's job easier.
Sure.
So that they don't run into frustrations of equipment problems and things like that. I know what happens when you have equipment that's questionable or not at 100%, and how frustrating it is, and how it doesn't lead to good patient care.
Sure.
You can get false readings. You can just not get readings to begin with. Setting up cases and setting up equipment at the beginning of the day is a very stressful part of the day for a clinician, and having equipment they can rely on, make sure everything gets going, and they have a good baseline that they can base the rest of the day on is essential. And I like to think my team helps them achieve that, and put them in a mindset where they can pay attention to the patient and not have to worry about the equipment.
Absolutely. So it's very rare that we get to talk to someone who was at the beginning of, like on the forefront of the technology that then
kind of the
became.
middle of.
Well,
not
that's
not
fair.
the very beginning.
Well,
it's kind of the middle.
That's fair. But I mean, you worked with the sort of
Yes.
the guy who sort of pioneered it all.
Yes.
So you got to see firsthand what that was like.
Yes.
And I mean, for perfusion, that started like in the 30s. So like those people just aren't around anymore.
Actually, curiously, the co-director of the research program at the hospital that I was working was one of the pioneers in perfusion.
Really?
That was Dr. Richard Jones, who had worked on heart-lung disc oxygenators back in the 50s.
Oh, wow.
He actually has a heart valve with his name on it.
Yeah.
I didn't follow that side. I did occasionally do small projects for him since I was part of the department.
Sure.
But it just kind of came full circle.
That's wild that
I'm
they both
working
work
on
in the same hospital, both Brown and Jones.
And it was a small hospital in Cleveland that just kind of had just had this amazing research program and attracted people over the years. It's since closed with the consolidation of hospitals into bigger systems. This was a small independent hospital, but I believe right until just before I started there, the head of surgery for that hospital was a Dr. Cross, and there's a K Cross disc oxygenator, which was an early heart-lung machine.
That hospital was doing great.
Yes.
That's amazing.
Yeah, they were great, and it was actually a sad time when that hospital closed.
Oh, I'm sure. So let me ask this, because I was building up to the question of you were there in its maybe not infancy, but its young, early adult life, right, for IONM. What is it like now to see how it is pervasive? I mean, I wouldn't say it's not used for every surgery, but it's used in a lot of surgeries.
It's definitely.
So what is it like? I mean, I don't know, and maybe it's because I'm a little egotistical. I would be very proud of the work that I had done. Do you feel any of that?
I am happy about participating in it.
Sure.
I've seen the field grow. I'd like to think I played a small part in it.
Sure.
But just amazing how it's grown. When we were doing it, most of what we were doing was the adolescent spine, scoliosis type, and now it's just expanded into so many different types of surgeries, affected so many people.
Oh, yeah.
And just, and then on the equipment side, going from back at that point where most of the equipment was either home brewed or at least home modified to work in the OR, to where now you've got several manufacturers making equipment specifically for the operating room.
Yeah. So through your career in sort of building these machines, was there ever a problem that was very difficult for you, but you got a lot of satisfaction out of solving? Like any obstacle that came up that you just didn't quite know how to do it? And the only reason I ask it that way is because I know a few people who've gone into engineering, and they are sort of pushing new ground. So it's not like you can go to Google and say, hey, how do I monitor someone's circulatory system, or how do I monitor someone's neurological system? So you guys are, and I mean engineers in general, pushing the forefront of what is possible. So when have you been able to do that, and what was that like?
Actually, back when we were first using PCs and adapting software that was available for the PCs for intraoperative monitoring, the challenge that we faced was we were using software that was industrial monitoring and control software that was meant to look at an industrial process, get data out of it, and then change the input or to it. The way monitoring works is you're inputting signals to the patient and reading what the response is.
Right.
So we kind of flipped the paradigm around, and that was the challenge.
Yeah.
We said, okay, this software can kind of do what we want it to, but we have to use it backwards.
Yeah.
And that's essentially what we did.
Because they sort of interact and record, right? They sort
right.
of
It was okay. This vat in the factory is getting too hot.
Yeah.
Let's turn down the temperature. Whereas with monitoring, we're stimulating something
Right.
and then looking at what the response is.
Right.
So, yeah, I mean, the input and output was there. It just wasn't lined up the right way for us. But we were able to take a look at that. And even though the software manufacturer, the vendor who had written that, told us that it couldn't be done, we didn't accept that.
Yeah, sure.
We said, oh, okay, that just means you can't help us. So
We'll
we
just
went,
figure it out.
yeah, we'll just do it on our own.
That actually is a very engineerish type mindset. I know a lot of engineers who think that way.
There's a problem. We just have to figure out how to
Yeah,
solve it.
there's a way to do it. I
Right.
just don't know what it is yet, but we'll figure it out.
Right.
That's every engineer I've ever talked to
Yes.
is sort of has that mindset, which I find incredibly fascinating.
Mm-hmm.
Well, I just want to thank you so much for joining us here on Scrubbing In. I thought it was an awesome interview, and I hope you had a good time. And
Yeah,
maybe we can
thank
get you
you
some
very
next.
much. I
Awesome.
always love talking about talking about the field. It's just passion
Awesome.
for me.
Well, thank you so much. I appreciate it.
Thank you.